Dear M1 A level and AS level students, hi everyone again, and I hope you are all well with these circumstances that we are in. We are continuing with the syllabus of mechanics. We are in moments today, one of the last two chapters, moments, and we are in the first part, only identifying and solving simple examples. We have part 2 tomorrow, inshallah, to finish introducing moments. Alright, what does moment mean? We may define the moment of a force applied on a body or particle in many ways, but I did choose the easiest ones. The moment of a force applied or acts on a body or particle is the measure of the turning effect, of the force on the body. Or we may say rotating, the force applied that rotating on the body to rotate about a point. How do we calculate, how do you find the magnitude or the value of the moment? By multiplying the force about a given point, as we'll see in the examples, or is the product of the force by the perpendicular distance of the line of action of the force from a given point. If this point, as will be explained now in the examples, not given in some questions for next part, we have to choose the point in convenient way to be able to solve problems with moments. For example, this is here the force of 8 newtons, to show you, just to explain the formula. And this is the point that we are calculating the moment about. The distance between the point and the line of action is d meters. According to the definition, dear students, this d, we are not interested in it. We are interested in look at the force. The force will act about this point in this direction. This is the meaning. We rotate, look. We rotate or turn by applying this force about this point. So this is the distance that we are talking about, x meters. By simple trigonometry that we know, since this is right angle triangle, because we said perpendicular, so this is right angle triangle. So this is the hypotenuse of the triangle, and this is the opposite. X is the opposite. So sine theta, that is given the diagram, is equal to the opposite, which is x, over the hypotenuse, which is d. So x is equal to d sine theta, since sine theta is equal to x over d. By cross multiply, x is equal to d sine theta. So the main rule, the main formula of the moment, dear students, it's f d sine theta, 8 d sine theta. Since the unit of the force is in Newton, the unit of the distance or displacement is meter, so the unit of the moment is in Newton meters. According to the given diagram, dear students, we must describe the direction. How we state the direction of the moment? Clockwise, because we are talking about rotation, yes, turning, rotation, circular motion. Rotate, turning effect. So we are talking or using clockwise and clockwise. This is the direction of the moment. So according, how do you do, not guessing, how do you do stay the direction? According to the force. The force is here, look. The force is here and the point is here. How you apply the force about the point? We follow the diagram. So this direction is clockwise. So in this is clockwise. Second example, we are given different diagram. Force 10 newtons in this direction. And this is theta between the point and action, the line of action of motion. This is the point P. So look in this direction. This is the force. You look at the arrow, the force, yes, the nose of the vector. Apply it about P. This is the direction that we are. We are turning in this direction, which is anti-clockwise. How do you calculate it? The moment equals the force given times x here. We are still introducing, we're still explaining. We don't need to do this in all the questions, the first two examples only. So 10 times d, the given, sine theta, because sine x is equal to x, sine theta equals x over d, so x is equal to d sine theta. So the moment in this example 2, it's 10 d sine theta anti-clockwise. Let's do more examples with numbers. We calculate the moment in each of the diagrams given. We are given the first diagram in part A. This is the force. This is the force 15 newtons this direction. And this is the point. Better to do, best to do this in the equation. Directly stated, like sketch, display the direction before we calculate. How do you calculate it? The moment equals to F d sine theta. F in this question is 15 newtons. D is 6. Sine theta, which is sine 30. From where this came? From here, dear students, don't forget. So here, this is the distance that we are interested in, which is 6, the given sine 30. By calculating, sine 30 is half times 3 is 3, so it's 45 Newton meters. Part B, this is the point B and this is the force, so this is the direction we are in. We are applying the force in this direction about the point P. So the moment is equal to FD. F in the question is 80 newtons times D, which is 3 meters, sine 90. Sine 90 is 1 in the calculator. So the moment in this question is 24 Newton meters. Simple like this. What's the difference between B and C, part B and part C? The direction. The direction was in part A clockwise. In part B, it's also clockwise. But look, part C, angle is 90 in both, but this is the turning effect. This is the way that the 7 newtons act about the point P. So the moment in this part is equal to 7, which is the force, times 2 meters, which is the perpendicular distance, times sine 90, which is 14 Newton meters. The difference between part D and the previous examples is what? We are given obtuse angle like this one, and the point is here. distance that we want is here. Distance must make 90 degrees to the line of action. What do you mean by line of action? Where's the line of force displayed here? Yes, this one. So this is the distance we are finding. This is the distance by the law. So when you write the moment that he wants is equal to FD sine theta, F is given, which is 7.5 newtons. D sine theta we don't know yet, but we are given distance between them is 4, yes? So 4 sine theta. But what is theta in this question? This is 1 to 1 this angle, because the triangle is here, which is 60. Because these two angles are adjacent or supplementary angles on straight segment or straight line. So 180 minus 120 is 60. And we remember, let me write, remember just more. We remember from C12 or P12 that sine the angle is equal to sine 180 minus the angle. So sine 120 is equal to sine 60. Sine 120 equals to sine 60. So we can do this in this diagram. Then by calculating, by using the calculator, 7.5 times 4, 7.5 times 4 times sine 60 is equal to 26 Newton meters. And what's the direction? This is the force and this is the point, which is anti-clockwise. Anti-clockwise. And the same for part C. I didn't mention the direction here, because this I put part C to differentiate in the direction, because this and this is the same angle. But what's the difference? This is the 7 here, and this is the point. So the direction is anti-clockwise. Let's see some different types of examples. We may add or subtract, we may find the net, the resultant moments. We may, because if you have more than one force, so you will have more than one moment. Making sense, because the moment is multiplying, or the product of the force times the distance. So we may have more than one force acting about a given point. So if we have such diagrams, we do add, like we learned exactly in chapter 3 and 4 in dynamics and statics. We add the forces in the same direction minus opposing the forces in the opposite direction. So the same for moments. So if we have many forces acting about a point on a body or a particle, we can find the sum of moments, but we have something important here. We must state the positive direction. What do you mean by positive direction? Clockwise, as we explained in the previous examples, or anti-clockwise. Explain what are we saying? What are we talking about? For each diagram, find the sum of the moments of each or of the set of forces about P. About P. P will be given according to the diagram. And all of the examples in this question are making the forces making 90 degrees. So this could be laminar, like we'll be learning in the second part, light rod, many like different types of. All right. So the first example is, the first force is 3 Newton, and the point P is here. So directly, when I have this, directly draw an arc, just to remind yourself, to show yourself where's the direction. We have 2 downward, 2 Newtons in this direction. So this is clockwise, and this is anti-clockwise. So they are opposing each other's in direction. Simple like this. So what's the sum of moments? To do this, help yourself in this way. You start solution like this. Step number 1, you do the moment clockwise, like this you do. It will help you. So do here, write the moments of the forces clockwise, about the point clockwise. So where's the clockwise? We have one force in this question, which is 3 Newtons. What's the distance between the force 3 Newtons and the point P? 1.5 plus 2.5 meters, 4 meters. Sine 90. Sine 90. So we have 12 Newton meters. So the moment in this question, or this part, 12 Newton meters clockwise. Second step, you do anti-clockwise. This anti-clockwise. We have one force acting here on this, about P anti-clockwise, which is 2 Newtons. And the distance between 2 and P is 2.5 meters. Sine 90, which is 1, which is 5 Newton meters, anti-clockwise, and here clockwise. Which is more, dear students? Clockwise is more than, the magnitude of clockwise is more than. So what's the sum now? The sum is equal to 12 minus 5, which is 7 Newton meters. What's the larger value, magnitude? It's clockwise. So the answer will be clockwise. Simple like this. Easy. Let's do another one. In this diagram, the value, or the position of P is here. The point P is here. Before we start, regarding what do you call this now? We are not interested. This device could be laminar, it's called laminar. We'll be learning this thing, beam. But we are doing light now. We don't consider the mass of this. We're just doing diagrams to apply the formula or the rule of moments. Fine? Fine. So, start with the forces from left to right. This is the first point, force, and this is the point. So this is the direction of the first one. This is the direction of the next one, the third 3 Newtons. And this is the direction of the 2 Newtons. Then you come here, new solution. You put clockwise. Step by step, you will find your answer. Then you do I have more than one force clockwise? Yes, I have. This one, 3 Newtons clockwise. Yes, do you see it? And the new 2 Newtons, it's also clockwise. This one is clockwise. And 2 and 4, they are anti-clockwise. So we have only one force acting about P clockwise, which is, what's the moment about 3 Newtons? Distance between the 3 and P is 1 meter. So times 1 meter times sine 90, which is 3 Newton meters. So you have one force, its moment is clockwise. Anti-clockwise, we have two forces, dear students. Then 2 Newton here, this one, and the 4 Newtons here. So anti-clockwise, we have two forces, 4 and the 2. What do we do? 4, what's the distance between 4 and P? Between here and here, 2. Between 2 and 1, 3. So times 3 meters. Since we have another one, 2 Newtons, and the distance is 1 meter. So I have 12 plus 2, 14 Newton meters anti-clockwise. And here, clockwise. What's the larger value, larger magnitude? So what's the sum or resultant of moments? Is the sum of moments is equal to 14 minus 3. Why we subtract? Remember, because anti-clockwise and clockwise are opposing each other's in direction, which is 11. What's the larger value direction? 14 is anti-clockwise. So this is 11 Newton meters anti-clockwise. Anti-clockwise. Last two parts for today in this example. Just I give you variant types of examples. So these are two forces in this direction and this P is between them. So the first step, dear students, show the direction. Then you come here to find the sum. First step you do clockwise. Which one is the clockwise? Is the 5 Newtons. So you can start with anti-clockwise. We can start with the clockwise. It depends on us. It's not necessary to start with the clockwise. So the clockwise is the 5 Newton. This one is clockwise, which is 5 times 3 sine 90 is 1, which is 15 Newton meters. Clockwise. Anti-clockwise, which is 8 Newtons times 1 meter, which is 8 Newton meters anti-clockwise. So 15 is more, so the sum is 15 minus 8, which is 7 Newton meters. What's the larger value, dear students? 15. What is the direction? Clockwise. So the direction of the sum will be following the larger value, the larger magnitude. The last part of our introduction today with moments. Sorry for this. We have the force 7 Newtons here and 4 Newtons here, and this is P. This is P. So this is the distance we are doing here. So this is P, this is the direction of 7 Newton, this is the direction of 4. So 4 Newton is, let me just put between this, solution for part D, clockwise, which is 4 Newton in this diagram, and this is 90. Focus well in here. So 4 Newtons, 0.7 is the distance between P and the force, 0.7 meters times sine 90, which is 2.8 Newton meters clockwise. Anti-clockwise, which is the 7 Newton. But what's the difference between this and this 4 Newton and 7? Acts with an angle. There's an angle. We want this one. So P, or the force, is not making 90 degrees. with the line of action like this example, or 4 newtons. You are given 60 degrees. So the distance between P and the line of action is 1.5 meters times sine 60 times sine 60. Then we calculate 7 times 1.5 times sine 60, which is 9.10 Newton meters. What? Anti-clockwise. Anti-clockwise. Since this is more, so the sum of moments is equal to 9.10 minus 2.8, which is 6.3 Newton meters. Since this is the larger magnitude, its direction anti-clockwise, so the direction will be anti-clockwise. It's only for explaining, it's an introduction. Most of students, they complain of the questions of moments because they don't do the questions in steps. Of course, much more important is the next part, because you're dealing with equilibrium and dealing with masses, with beams, uniform bodies and non-uniform bodies, the questions that come in the past papers and the exams. Wait for us soon, within a day, to do moments part 2. I wish you the best again, everyone and everywhere.